Good morning, everyone. This is week number two, summer 2024. And I'd like to recap on what we did last week and what we will be doing this week. So let's take a look at this, other contents here. Last week, we have gone over mathematical principles, the number system, the simple grammar mathematics, and truth table, okay? Introduction to functions. So all of these, the top, right? Math principle all the way up to truth table. These are the things we use very often. We use throughout the courses. And the concept, right? We have introduction to functions, and we talk about function in, so we have definition of function, right? So definition of function, right? And we know a function is a rule that assigns each input exactly one output. So it functions as a rule, and we take this rule, and this rule takes input, and it produces output, okay? The output used to be called y, but in this course, you're gonna learn how that's gonna be called f of x. F of x notation is very important notation because it tells you the input is x, and the input is applied the rule of the function and produces an output. So f of x itself, it tells you the input is x, output is f of x, and f is the rule. Okay, so it's in a compact form, tell us what a function is and how to express it. So in the future, you will be using these notations like y equals to f of x interchangeably. And sometimes when y is not present, you can just use f of x. Okay? All right, so that's notation-wise. And under this notation, right? And at the overview, we talk about this course it's about in all possible, well, not all possible, the many rules used in mathematics in the academic level. Okay, so what are the rules we have learned? The function we have learned, right? Rules we have learned is last week, right? When input is any number, the output is a constant, right? That rule. What is that rule? The function is f of x equals to constant. We studied that function last week. And what else rule have we learned? The next rule we have learned last week is that the input is x, f of x, the output is x. Output is the same as input. So f of x is the same as the input, right? And that function often, in a more familiar form you have learned before is y equals to x. And by looking at these two functions, and we will be able to get a glimpse of the other function you guys learned before, which is mx plus b. Okay, this is called a linear function. And it's a line. You guys learned that before. So by adding, subtracting these two functions in any way, we get a new function, linear function. So this function, we can also write it as f of x equals to m of x plus d. It's linear. Okay. So we use these functions in calculus, yes. Okay, all of these functions we study in the first week and throughout the semester are the functions you will be using and used frequently. Okay, so these are the linear. And what else function are there? Right, so after we studied, you know, the linear, we study the nonlinear, quadratic, degree is 2. And what is that? Simplest form of that function. That function is f of x equals to x squared, right? And what else? And of course, we have f of x equals to x raised to the power 3. And we're not going to continue to study these functions like power 3. And we're going to look at other functions, okay? So up to this point, and you might be reminded of the other function that you have studied before, ax squared. This is trinomial. And this function is used and tweaked in many ways and in many forms. Okay, and you will see the tweaks in the semester throughout this, here and there in the semester. X raised to the power 3. This function is, all of these functions are very important. X raised to the power 3 is one of those important functions, is also used in calculus in particular, okay? And of course, we study the domain, we study the range, we have studied the graph. That's what we studied last week about these functions. And whatever function we have studied last week. And this one, the absolute value function, which is right here. All right. The absolute value function, okay, is right here. I have a specific lesson about absolute value function. Very, very important function, right? You can see all of these functions, I have lessons on them, right? X raised to the power 3, cubic root, square root, cubic root, and we're going to get to the absolute value function. It's a very important function, super important function in calculus 1, okay? You talk about 20, 30 points from calculus course. So you know this function, you need to know this function very well. Domain, graph, and we discussed this graph and the properties, right? So these 2 lessons about absolute value function is super important. So please study very carefully. If you have studied it, you should remember where you did and where you find those lessons. You might need to study them again. Okay, more. Right, so very important function. The next one, of course, is a square root function. And the following one is a cubic root function. So we studied all of these functions last week, and one more, reciprocal functions. Okay, they're domain range graph, right? So these are the basic functions. These are the first 8 basic functions, right? I think it's 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. And we also introduce the concepts, very important concepts, such as one-to-one function. Right? What makes one-to-one function? And one-to-one function, what is not a one-to-one function, right? What is not a one-to-one function? So we studied that last week, right? Was the opposite of one-to-one function. And one-to-one function, of course, has inverse, right? The domain and range of two functions that are inverse to each other, and what's their relationship. We have extensive studies in that in last week. And also, increasing function, decreasing function. Okay, even function, odd function, odd function. Okay, so last week we studied all of these concepts, and specific functions. Of course, we're not limited to that, right? And how to deal with it. There's a lot of contents. Okay, and so for each one of the 8 functions, I would like you guys to think which one is even, which one is odd, which one's increasing, which one is decreasing, which one is neither increasing nor decreasing, which one is neither even nor odd, right? These need to be thought of. So that's why we introduced these concepts at the very beginning. So in the future, when you encounter a new function, you might think of applying these concepts to those new functions you encounter. Okay. Now, after that, we studied exponential function and logarithm function. You can see exponential function and logarithm functions were studied in pairs with log base 2, base 3, and base e. Okay, so this part of the contents, okay, this part of content, you can see we take them gradually, right? For base 2, exponential, let me use red. Exponential base 2, logarithm base 2, they're inverse function to each other, right? Domain range, one's domain, the other's range. And exponential log base 3 and base e. Base e is the ultimate one we want to get to, because in calculus, you pretty much only use exponential logarithm functions with base e, that natural logarithm and e to the power x. So these few sections, they're very important, and you also get to apply these concepts, right? Increasing, decreasing, even, odd, one-to-one, and so on and so forth. Okay, so I hope you guys get the idea, right? I hope you guys get the idea. So all under the function, the concept, right? Under this rule, we have different kinds of functions: one-to-one, not one-to-one, increasing, decreasing, even, odd. And to apply these concepts to all of these different rules, and you use these rules very often in calculus. And so let's add to our rule, right? The rule of function. And the output is 2 to the power x, right? Domain range, inverse, increasing, decreasing, these concepts, 3 to the power x. And the next one, e to the power x. We study them in the context of comparison, okay? Comparing the 3. And they are inverse, right? They're inverse. Inverse functions are functions, of course, right? That inverse is input goes into the inverse, and that inverse hold on. Okay, that inverse function is log base 2x. And its domain range, etc. And the inverse function for 3 to the power x, log base 3, right? And for e to the power x, ln x, right? So we studied all of these rules just last week. You guys are amazing. You guys did so much work last week. Okay, congratulations. And you did 7 quizzes. 7 quizzes. I'm going to make the solutions available today. And before that, and I like to have the summary done for you. And so it's time to reflect. What have I learned last week? And what are we going to learn this week? Okay. So homework. Okay. I do want to make a point about homework. Last week's homework. Homework number 1, right? So all of these are pertained to, was basic, right? The last set of homework, rationalizing the numerator. These questions are exactly the same question from calculus text. I only just take the algebraic part from that calculus context. I highly recommend you guys practice doing these questions, okay? Even though they're algebraic contents, but they're also calculus contents. If you know how to operate these algebraically, you already give yourself a leg up, okay? And I have homework guide on these. If you have any questions, please don't hesitate to reach out to me. I will check your work. If you have any doubt about the answers and stuff, don't hesitate, just ask me. Okay, so that was the contents last week. Okay, so let's look at this week. So wow, we have studied so much last week. Okay, that's 2 weeks of work in a regular semester. Okay, so let's look at week number 2. Week number 2 is entirely about trig function. It's entirely about trig function, and not all the trig function yet. Okay, we introduced the definition of all of the trig functions, right? Intro to trig functions definition. So I teach trigonometry in a very direct way, which is I summarize as A, R, D. Okay, if you follow my idea, you will see, right? All the questions you are going to encounter is either A to D or D to A. Either A to D or D to A. Okay, so this week I will show you that. D to A. Let me get the other arrow there. So all the questions you're going to have is either A to D or D to A. How so, right? We first introduce a definition, right? And we talk about the importance of, unit circle, Y unit circle, and apply, definition. So all of this at the beginning, right? It's an A to D. So all of these, right? Apply trig definition, pi over 6, that's A to D because you know the angle. A to D, A to D, A to D, right? So all of these A to D. A to D applied. We're doing these curves, right? And it's a sign, even odd, that's sort of discussion. So all of these is the first part of the A to D. And next part is arcsine. Arcsine is actually D to A. So how do we see it? Take sine, for example. Take sine, for example, right? Sine takes angles as input, right? So sine function, okay? Sine, okay? And of course, the output is sine of A. The input are angles or radian. It doesn't matter what degree or radian, right? So in this semester, we want you to shift from degree to radian. So you only use radians because in calculus, you only use radians. Okay, so that's the setting. So in most part, up to this section, right? From the beginning. From the beginning. Okay. All of these are definitions, and most of the part we are doing, right? So all of these parts, primarily we are doing A to D. We're doing A to D. Okay, like graphing, plotting points, right? I went over a lot of the basics. Okay, the greatest details you can find anywhere. Okay. All right, so that's A to D. Next, right, after quiz number 10 is to A. Okay, A to D is that the angle, you get the ratio. Sine ratio is defined. And D to A is about arcsine is about D to A. It has its own domain and range, as this lesson is talking about the how and the why, right? It's from ratio to angle, right? So the other function we're talking about D to A, right? So A to D in this setting, and D to A is in the following setting, right? We have X as a ratio, right? Not ration, sorry. Ratio, and then arcsine, it produces angle. And of course, this angle is going to be in a very specific range. Okay, you see the details. And that's related to the domain and range. And ratio, of course, ratio has to be between -1 to +1. You see that details in the discussion, in those relevant discussions. So ratio, right? So that's D to A. You can see A to D is angle to ratio, and D to A is ratio to angle. Okay, and the next topic is a composition. Composition of sine and arcsine. So that lesson is sometime A to D and then D to A. So A to D, D to A happens in one expression, right? So composition, such as you will see arcsine, sine, right? That's inside is A to D. And after you get the D, you apply arcsine is D to A, right? So this is arcsine. And there are other situation. The other situation could be sine of arcsine. Sine of arcsine, right? So for arcsine part is D to A, right? So once you get the A, sine of A, that's A to D. Okay, so composition is doing A to D, D to A, depending on the order, depending on what you're given. So I wrote some text for you to read, and also there's a recorded lessons, and there's summary, A to D, and last but not least, okay, I'm just composing the last quiz number 14. It's not finished, and I'll make them available later today. And the last 3 sections is entirely about D to A. It's entirely about D to A. Okay, D to A means that you're solving equation. For example, you're given equation sine equal to say 1/2, right? So these lessons we talk about how to solve sine equations. What are sine equations, right? As a sine function, right? We know the ratio. We know the ratio. So this is a given. This part is known. Okay? And this part is to be found. So that's a typical question of D2A. Right? We know the D to find A. So how do we do that? So these 3 lessons is about that. So that's all for this week's work, even though I summarize it in this short clip, but you do have much work to do. And if you have any questions, please don't hesitate to reach out to me. And I'm here 24/7 for you. And have a great week. Thank you for watching.